Okay, we just figured out there are 29 numbers. We now need the middle number. There are a couple ways we could do that. We can use the formula n plus 1 over 2, which would be 29 plus 1 over 2. And we realize 30 divided by 2 would be the 15th number. Okay, you could go ahead and list the numbers in order like this and count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's the middle. And check yourself this way. Okay, same direction. Or if you don't want to relist them, you can do it from here. You go in 1, in 1. The next number, the next biggest number, next smallest number, next biggest, next, and go all the way in. Okay, either direction. You then want the median of the medians, and so you would do the same thing, and I will tell you that you will come out right here and right here. Okay, so if we had, for this one, we'd have 15 numbers, actually 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. So 14 plus 1 over 2 is 15, which means the median of that part would be at 7.5. So 1, 2, 3, 4, 5, 6, 7. It's right in the middle. Again, our notes say that we would put a 76 here and a 76 here and include it. We are not going to do that at all this year. Okay, so it's just like this. So the bottom quartile then is going to be between 65 and 66, or 65.5. And the upper quartile, if you were to do it again, is going to be between, and I didn't mark it at the right spot. Okay, I actually paused it, and you may notice that my numbers are now smaller. I had missed a few over here, so I corrected that. It shouldn't affect your notes because we only dealt with over here. Okay, so we still have Q1, or quartile 1 of 65.2, a median, or a Q2 of 76, and quartile 3 of 88. Okay, and again, note there are several different acceptable ways to calculate the quartiles, but the 83 will exclude the median from both halves when there's an odd number of observations excluding it. Okay, so we've calculated that. You should be able to do that by hand. Now we are going to compare distributions. And if you need to, you can rewind and look at that part again. So we have these two distributions, okay, of student test scores from period 2 and period 4. And again, remember, whenever you're asked to compare distributions, you want to compare shape, center, spread, and unusual values. And you want to do it in the context of the problem. To compare, you should use phrases like the male distribution has a higher center and is more spread out than the female distribution. So let's do shape first. Okay, and you can shorthand this or copy it later. But it says period 2 is symmetric while period 4 is left skewed. And you might want to say period 2's test scores are symmetric. That gets the period 2's test scores are symmetric. So that takes care of the shape. Okay, the next part you want to look at is the center. We don't know exactly where the center is, but if you were to look at it, the center here is about here, and we're counting up numbers. The center here is probably here. So we could say something like period 2 has a lower median and is less spread out. So that's talking about the spread, because period 2 is from here to here, while period 4 is more widely spread. And again, you probably want to talk about test scores to add the context. And then lastly, unusual values. We don't know if we have any outliers, but it appears that period 4 may have 1 or 2 low outliers, while period 2 doesn't. Again, we would need to check that, and we're going to talk about how to do that in just a minute. Okay, so specifically talking about how to do that, we need to know the 5-number summary. So the 5-number summary of a distribution is the list of the minimum value, Q1, median, which again is Q2, Q3, and the maximum value. Okay, a box plot is the graphical display that uses the 5-number summary to help picture a distribution. All right, note the length of the box in the middle of the box plot is the interquartile range. And the length of the entire plot is the range. So it's going to go something like this. We have the min, wherever Q1 is, to the median, so the Q2, Q3, and the max. And you really don't need these lines right here. So that's a box plot. The interesting thing about a box plot is there are the same number of numbers here as here. This one has 25% of the data. This part has 25% of the data. But these numbers are more spread out, so it easily shows you spread. Okay, so we have 25% of the data, 25%, 25%, and 25%. Okay. All right. A distribution has outliers, or if a distribution has outliers, they are usually marked separately. So if we had outliers, we would actually mark them like this, okay? And that's called a modified box plot. So instead of this, this might be the min, Q1, Q2, Q3, and if the max was right here, but we had an outlier, the max was actually an outlier, we'd go to the next one in, and that would become the max. And this high number that was too high, and I'll tell you how to tell, becomes an outlier. Okay, so box plot, modified box plot. All right. So we need to determine where we put these little, or how we figure out if there's an outlier. And that is a lower fence and an upper fence. The lower fence, and you will absolutely need to memorize this, is Q1 minus 1.5 to IQR, and I'll go over this in class a little bit. Okay. And the upper fence is Q3 plus 1.5 the IQR. Any observations that are outside of these fences are considered outliers. If there are outliers, the whiskers extends to the most extreme observation that is not an outlier. Okay? Are there outliers in the test